Hi, Mrs. Lesherville.
Hi, Mr. Knott.
So we're going to take a look right now at the question that you just answered, where we have a material that we're going to be drilling some holes into and see if that changes its behavior when placed in the water in the tank behind us.
So I'm going to predict that many of you thought that if the wood floated to begin with, once we drilled holes in it, that then the wood's going to sink, or at least go down a lot further, because you're going to think the water's going to kind of rush up, right? Go in those holes and push it down. That would be my guess, that we're going to see that answer a lot. So let's see.
Let's see. So we're going to start by placing the wood into the water and noting the water line on the wood, just to see, that'll be our starting point. So there it is. You can see it's floating. I'm going to use a Sharpie to indicate that water line on the side of the wood for our before and after. So the water line falls right here. Okay, I don't know if you can see. So now we're going to take a drill and put a good amount of holes in the piece of wood. Got 5 so far, Ms. Lesherville. Should I do more than that?
Well, I'd like them all the way down, because I feel like they're going to think if it's not all the way down that it's not the same.
All right, there's 6, 7, 8, 9, and 10.
Okay.
So there we have the wood, holes all the way down from end to end, 10 holes total, right? So some of you may be satisfied with that. Some of you may say, well, you know, if you put more holes in, well, let's take a look anyways at this point to see. So with 10 holes in the wood, we're going to place it back in. There's our water line that we had from before.
I'll bring you a little closer.
So there we can see the wood floating at what appears to be the exact same level. There's the Sharpie right at the water line. Even with the 10 holes in it, it would appear as though the material is staying at the same position in terms of its flow.
Now, I have another what if, because if you were here with us, you would say, well, what if you push it down under the water? Then what would happen? So let's see. Let's push it down. We're going to fill all those holes with water. Make sure the water gets in between them. And we can see it is still floating at the same exact level, even though I pushed it down under. We're going to stop the video here and let you go back to your problem to just kind of observe what happened. So what exactly is happening here?
Well, we want to look at why it didn't change. So the floating level, obviously, once we put the holes in it, one would think, well, it should change somewhat. But what we're doing really is we're not changing the density of the material. So when you think about what's happening inside of it, the particles and how close they are, even by placing holes in it, we haven't really changed how those are situated. So it continues to float at the same level. We might be thinking a little bit of like a boat where water might rush in through the holes. And that is true in those scenarios, but that's due to the fact that air in a boat is actually allowing the water to come in to be replaced when there's a hole in the boat. So in this case, we're not looking at I guess a container of air as a boat would be.
So you said we're not changing the density, and that makes sense to me because, you know, we took some mass out of this by drilling holes, but we also took volume out. So we didn't affect that ratio because we took some of each out. The ratio stayed the same. And I could have done a number of things with the wood. We could have sliced it up into smaller pieces instead of poking holes in it. We still wouldn't have changed the density. We would have seen the same results.
Mm-hmm.
You know, we could have sliced it into half. No matter what we do to manipulate this, we'll probably see that the floating is going to be the same. Now, wood is a different material than some things, and so a lot of times you'll see like wood that's sunk to the bottom of a lake, or you'll know that, you know, eventually this might absorb the water, and that could change its density. But as far as changing the density just by changing its shape and size, then we're not changing that density. It's the same.